I told you start in chapter 3. Starting in chapter 3. I copied. First of all, eyes up here. Part of the problem with inequalities is people maybe don't remember how to read them quite correctly. So this is ax plus by is what? Less than c, because it's pointing at that, correct? This is less than or equal to c. This is ax plus by is greater than c, because the big side is facing the bigger, the two things is facing this side. However you want to look at it. The alligator eats the bigger side, whatever you want to say. Ax plus by is greater than or equal to c. Okay? Now, ladies and gentlemen, if this was an equal sign, as opposed to an inequality, there would be only one point, one ordered pair that would make the equation true, correct? Yeah. Since it's an inequality, there's a whole heck of a lot of ordered pairs that could make that inequality true.
Is that where you shade?
Yeah, so today we're going to shade on the coordinate plane all the ordered pairs that would make the inequality true. Okay? So that's what we're looking at. The solution of a linear inequality is just an ordered pair that makes it true, is one solution. There's tons of solutions. Graph of a linear inequality is shading on a coordinate plane all the points that make the inequality true. And the half plane is pretty obvious. Here we go. Tell whether the given ordered pair is a solution. So this is x and y, so what do you think I do to tell whether it's a solution to this? Plug it in. Plug it in. 5 times 0 minus 2 times negative 4, is that less than or equal to 6? Is the question. 0 plus 8, is that less than or equal to 6? It is not true. So, no, it's not a solution. That is not true. Okay? So let's try this one. Plug it in. 10 minus 4, is that less than or equal to 6? Yes, it is. 6 is less than or equal to 6. It's the equal part. So it's true. Easy enough? All right. On a side note here, make yourself a nice little side rectangular box here. Just as a refresher. If it's less than or greater than, you do a dashed boundary line. Okay? Dashed boundary line. If it's less than or equal to or greater than or equal to, you do a solid boundary line. And I'll show you what a boundary line is in a minute. Okay? Now, when it says to graph this, again, seating chart comes to mind, but I'm hoping I don't have to. When I graph this, I, just for graphing purposes, make it an equals. It helps me. Like, okay, well, I got to draw the line. So I'm going to write x equals 5. What kind of line is that? Yeah, it's telling me all the x values are 5. So 1, 2, 3, 4, 5. I'm going to go over here and just put a couple dots where x is 5. I'm not going to connect them yet until I check to make sure, is this going to be a solid or a dashed line? Solid. So now I'll connect them with a solid line. This is a boundary line. That's what they mean when they say boundary line. It could be solid or it could be dashed. That's a boundary line. Now we have to decide what half plane to shade. This is saying, this is an easy one because it says all my x values are less than or equal to 5. So is that going to be this side or this side? Yeah, everything over here has an x coordinate that's less than or equal to 5. And the reason it's a solid line is because everything on this line will also make that true. Correct? Okay. All right, turn it over. If you're done. You done? Okay, here we go. Now, before you jump in, it's a lot easier than, again, for me, I do this just for graphing purposes. I make it in equals, just for graphing purposes. What form is this?
This is standard.
I'm telling you, when it's standard form, you could put it into y equals mx plus b, but it's a whole lot more work than making a cute little baby table. If you had Butler, she called them baby tables.
Yes, she did.
Okay? So this is finding the x and y intercept so much easier. If I plug in 0 for x, doesn't this go away? 3 times 0, yes? Divide by -4, what's y? Yeah? Plug in 0 for y, this goes away. What's my x value when y is 0? 4. Oh, look at that! I got 2 points. I can graph this line. So I'm going to plot the points. 1, would you look at that? 1, 2, 3, 4. Don't connect them yet. Shh. Is this going to be solid or dashed? Because it doesn't include anything on the line. None of the solutions are on the line, so it's dashed. Okay? Now, how do I decide? I'll wait. How do I decide which side to graph? Do you guys remember? I got to plot. It's either all of these ordered pairs or all of these ordered pairs.
It's probably all of those.
Well, maybe.
That's what a graph is. Maybe.
I can test for sure. What do I use?
You can pick 0, 0.
This is the easiest point to plug in. If your line is not going through that point, use 0, 0. If it's going through that point, pick another point. Not on the line. So let's try. So test with 0, 0. So plug it in. 3 times 0 minus 4 times 0. Now you got to use the inequality for that, for the test. Is 0 greater than 12? No. So that tells me that 0, 0 is not part of the solution. So I got to shade what side? I got to shade this side.
Wait, I was just going to do whatever one's on top, and that's the top being less than whatever.
That's when it's in y equals mx plus b form.
So if you change it in y,
Then you could just look and see if the y is greater than, then you shade the top.
We'll just change it.
I don't care what you do. I just think it's more work, but it's up to you. This tells me then, ladies and gentlemen, that any single point here, if I plug it into the inequality, will make it true. Yeah? Okay, I know you're anxiously awaiting the story problem, so let's do it.
I'm so excited.
You have 2 part-time jobs, one that pays $9 an hour and one that pays $12. X is hours at $9. Y is hours at $12. How many hours at each, okay? It says you'd like to earn at least $240. That's an inequality speaking to me right there. At least. Write an inequality describing the possible amounts of time you can schedule both jobs. Graph the inequality. Identify 3 possible solutions of the inequality. Okay, well, let's start with write the inequality. If I work a certain number of hours at $9 an hour, and I work a certain number of hours at $12 an hour, I'm not putting anything in between here, but I know that I need 240. Then I decide what goes here. Ben.
Why don't you just work at this job and it's $12 an hour full time?
Well, that's one of your options.
Yeah, I know.
But maybe you can't get full-time at that $12 an hour job.
Yeah, Kmart is full.
Okay? So, do I need this side to be greater than or this side to be less than this? Greater than or equal to? I can earn more. All right? Now let's make our little table. Plug in 0 for x, and then y is 20. Plug in 0 for y, X is 26.6 repeating. I can work with that on this graph. I can graph that, sort of, close enough. Over 0, up 20. 26.6 is about like here. Solid or dashed?
Solid.
And do not go into the negatives because that would just be annoying and wrong. Why would it be wrong?
Maybe
You
you
can have
break,
negative money.
maybe you break something.
Okay, Ben. All right, now let's try 0, 0 to see if it makes it true. 0 plus 0, is that greater than or equal to 240? I don't think so. So we got to shade this side. How's that? All right. Now it says identify 3 possible solutions of the inequality. Well, you've got this beautiful graph. So I could do this point right here. 32 is one possible combination. This tells me, what does this point tell me? Who can I pick on? Madison.
That you work 30
Hours at what job? And then 2 hours at, okay, that's one possible combination. So I could do this one. That's 24.18. There's another combination. 24 at $9, 18 at $12. These will all give me more than 240. If I picked a point on my line, I would get exactly 240. But, you know, this just says pick 3. So 6 and 18. There we go. 3 possible combinations. Doable?
Yeah.
Okay. This one is really fun. Let's do this. Okay, graph. So what does this tell me right here? I'm going to do what? From the parent function, it tells me to do what? Go down 1, right? The minus 1 tells me to go down 1. The plus 2 tells me to do what? Go left 2. The negative tells me to do what? Flip. So here's what I want you to do. If you have 2 pens, it would be great. If not, just watch. So we're going to start with the parent function. I'm just going to do it lightly. Here's the parent function. Yeah? Here's my parent function. I'm going to start by moving down 1 because I can. Moving down 1. There's the first move, down 1. And then what should I do? Probably it would be easiest to do now. Left 2. So move my vertex over 2 and just kind of sketch my graph. So I got, can you see the 3 movements there? I got 2 movements. I got 1 more movement to do. What is that?
Flip it.
Flip it. So then from this point, I can actually draw the actual graph. Voila. But it's an inequality. So we have to shade the correct side. Ruh-roh. Who says that? I love that.
Scooby.
I love Scooby-Doo. Okay. So you can test with 0, 0. Test with 0, 0. Okay? Or any point. So let's plug it in. 0 is less than or equal to negative absolute value 0 plus 2 minus 1. 0 is less than or equal to, let's see. Absolute value of 2 is what?
2.
And that's negative.
Negative 2.
So negative 2, take away 1 is negative 3. Is this a true statement?
Nah.
No.
It's not true.
I don't think so.
So what side do we graph?
The bottom.
We got to graph down here. Shade down here. Okay?